Anyway, guys, I hope you are preparing for your forthcoming examination. Now, so as all know that my name is Muhyiddin Waliu, popularly called what Dr. Nefon. So I just want us to look at this question very well. Now look at that question. We're given that a helium atom has a mass of proton and the mass of neutron to be 1.0073 AMU and 1.0087 AMU respectively. Find the binding energy. You see, this is a UTME questions. You see, if you want to calculate binding energy, you are going to use what? Delta what? MC square. Now, so what do we call binding energy? Binding energy is the what? Is the energy required to break down the what? The nucleus of the atom. So that's what's called the what? The binding what? Binding energy. Again, what's binding energy? Binding energy is the what? Is the amount of energy required to what? To break down the what? To break down the nucleus of the atom. Now, so that means E is what? Is the binding energy. Delta M is what is called the mass defect. Mass defect. And C is what? Is the speed of light. That means before we do anything, we have to what? We have to calculate our what? Our mass defect. So mass defect has a formula: number of neutrons multiplied by mass of neutrons. Now everything plus number of proton multiplied by the mass of what? Of proton. Now all minus original mass of the nucleus of the nucleus. Now from here, given that mass of nucleus is equal to mass of nucleus has been given to be able to be 4.0015 EMU. Now, so check your formula. The delta M is what is called the mass defect. Is equal to what? The number of neutrons times the mass of the neutron plus the number of proton times the mass of the proton minus the original mass of the nucleus. So that's how to calculate our delta M. So delta M will now be equal to what? So now if you look at this now, what's the number of neutron? Now in helium, notice how to write helium. So helium has the mass number of 4 and atomic mass of what? Of 2. So here, from here now, the proton number is 2 and the neutron number is also what? Also 2. Because mass number equal to what? Proton number plus neutron number. So 2 plus 2 will give us what? Will give us 4. So that means the number of proton and the number of neutron that was are 2. That means 2 multiplied by, so what's the mass of the what? Mass of the neutron they give us. So if you look at that question now, the mass of the neutron is because they mentioned mass of proton first, that means the second one is what? Mass of the neutron. That's 1.0087, right? Now plus 2 into bracket what? Plus 2 times 1.0073. That's what? That's mass of the what? Mass of the proton. Now everything minus the original mass of the nucleus, that's 4.0015, right? So we are going to find our change in M to be what? To be, now if you multiply the what? If you multiply the mass of the nucleus, mass of the neutron, so let's say 2 times 1.0087, right? So we are going to get 2.0087 0.0174 plus now 2 times 1.0073. So we are going to get 2.0146, everything minus 4.0015. So now, change in m will now give me what? Now if I add them together, if I add 2.0174 plus 2.0146 together, so I'm going to get what? I'm going to get 4.032 minus the original mass 4.0015. So everything will give me what? Minus what? Minus 4.0015. So I'm going to get 0.0305 EMU. Now, actually, this is a UTME question. UTME asked this particular question. So they asked this particular question. Now, guys, so what to calculate here is what? Is only what? Is only the mass what? The mass defect. So we have not calculated that what? Our data, our E. So E is now equal to what? MC square. That is E equal to. Now, but guys, do you know that we cannot use this mass like this? We have to convert AMU to what? To kilogram. So don't forget, 1 AMU is equal to 1.066 1.6606 1.6606 times 10 raised power minus 27. So that means 1 AMU kilogram. So 1 AMU is equal to what? 1.6606 times 10 raised power minus 27. That means before we can use our data M, we have to convert it to what? To mass, right? So it now be what? It's now be what? What we get? 0.0305 multiplied by 1.6606 times 10 raised power minus 27 multiplied by, so what is speed of light? 3 times 10 raised power 8. So our E will now be equal to what? Now 0.00305 times 1.6606 exponential minus 27 multiplied by 3 exponential 8. So we are going to get 1.519 times 10 raised power minus 24 minus 21 joule. So or E equal to what? 1.52 times 10 raised power minus 21 joule. So that's the final answer. So thank you. Subscribe to my channel for more of questions like this. Thank you so much.